Okay, so what we're going to look at is some plotting in this exercise. So we're going to be using the healthcare data in the US as our data set, and from this we're going to use the matplotlib to be able to create our charts that will plot our data. Okay, so we'll pick off an x value and a y value, and then we'll use pandas to be able to read that in. Okay, and then we pick off each of the columns of the data and then plot that as scatter plot. We'll also save it as a PNG and in an SVG format. Okay, so that's what we're going to try. So we'll just open up our cloud, and here we are here. Okay, so we'll just open up the PDF here. And just copy it. So and I'll call it 5.py, and I'm just going to paste it in. So it doesn't come in too well from the PDF, but I'll just clean it up. Okay, that's fine, and then we just do our plot.save, and that's it. Okay, so Control X, Y, save. Okay, so the data set we're going to be using is here, hopefully. There it's there. Okay, so it's some data that you can download that's related to infant mortality, heart disease, and so on. So we can actually analyze that data if we go to this link here. Okay, so it's called Pandas 2. Just to show what it should look like. Okay, so all that's happening here is it's calling up our Python script on the back end. So we should be able to plot heart disease with suicide death rate. Okay, and that's what you get there. So you can see it's not that correlated to them. We should be able to look at the linear regression statistics for it, and this gives us our R² value. But certainly one thing that is related, and it's related to smoking, is the suicide death rate and stroke. Sorry, it's the stroke rate with cancer, because both are linked to smoking. So if we plot that, we can actually see there is a fairly strong correlation there. So each point is a state of the US, a state in the US, and we're looking at the death rate for strokes and the death rate for cancer, and we can actually see there is a very strong correlation, a positive correlation in this case. Okay, so that's our data. So let's give this a try. So we do Python 5.py, and there we go. Okay, so we've plotted the infant mortality rate in heart disease, and there is a correlation there. You can actually see that as we increase infant mortality, we tend to increase the heart disease death rate. Okay, so for the next thing that we'll do is that we'll now plot our suicide death rate with cancer death rate. Okay, so you see it's a bit more random in this case, so it's difficult to say that there's a correlation between the two. Now what we're going to do is that we're going to try and see if we can actually plot a straight line. So with this we're going to import a library that will give us our stats. So in this case it's statsmodel.api, and we'll just put it in there. Oops. Okay. Okay, so let's try that one again. And now what we'll do is we'll bring in the code which will allow us to define the straight line. Define a straight line. So we'll just copy that. Okay, so there's an if statement, so we need a tab in there. And a tab in there. And so we'll just remove that. Okay, so we're going to plot the scatter plot. And then what we're going to do is we're going to find out the best fit for our correlation there. So in this case, what we do is we run the polyfit method with the x and the y data, and that's going to give us the gradient and the point at which it cuts the y-axis. Then what we'll do is we'll draw a line given those two values, and we'll just plot it. Okay, so the x plot gives us our x values, and then this will give us our y values. That's the equation of a straight line, mx plus c, we would normally use them. Okay, and then what we'll do is we'll print out the equation of the straight line, and then also the statistics that relate to it. Okay, so mainly we're using NumPy here to be able to do our analysis for the statistics, and then we'll use this OLS to be able to give us the data around the linear regression analysis. Okay, so we'll just run that. And there we go. Okay, so this time we have a straight line, and that's taken from the best fit that it can find in terms of a linear equation. And along with that, we've actually got the data here about the equation that will fit that. So that straight line is minus 0.521 times the suicide to death rate plus 171.526. Okay, so that defines that there. So it cuts the y-axis about there and has a gradient of minus 0.5 in this case. Okay, so that's the delta y over the delta x, gives us our gradient. Okay, so that's our values there, and you can see that we've managed to print that out. Just let's see if we have the last line there. So one line here, we've indented too much. That's why we didn't print out the linear regression statistics, and that we've indented it so it would come in with the if. So now what we'll do is we'll just run it again, and this time we should see our linear regression statistics coming out. So that's fine. So here we go, there is the r squared value, we have the S statistic, and so on. Okay, so this gives us our linear regression statistics. We've used NumPy to be able to get that equation of the straight line. Okay, so what to do is to go ahead and actually try out the rest of the tutorial there for the different values. So after that, what we'll do is we'll look at some other things like educational attainment in the US, and then we'll go on to some crime-related data. Okay, so that's just given a quick overview of how we can plot a straight line and how we can determine our linear regression statistics.